everyone, welcome back to my channel. In today's video, we are going to touch on statistics, specifically on condition probability and tree diagrams. So let's first take a look at an example. From experience, it is known that a packet of seeds contains 80% viable seeds. If viable seeds are planted, then 90% are expected to grow into plants. If non-viable seeds are planted, then 15% are expected to grow into plants. Draw and label a tree diagram to show the probabilities of plants growing. So you want to draw a tree diagram, and in statistics, a tree diagram basically shows a series of events. So you have two things that are going to happen, and then it shows the probability, and then it also shows what happens next. So let's make use of tree diagram and draw based on this word problem here. So there's two things happening here, right? You either get a viable seed or you get a non-viable seed. So in a tree diagram, you want to draw that, right? You either get a viable seed or a non-viable seed. And let me just quickly define those variables. V represents viable seeds. V prime, non-viable seeds. And so now that we have that, we want to write the probability. So here it says it contains 80% viable seeds. So in decimal, that will be 0.8. Non-viable seeds, well, it doesn't say the probability, but we already know because it's the opposite of 80%, which means I want to do 100% minus 80%, right? So 100% minus 80% is 20%. 0.2. And now moving on, we have other things happening. Here it says if viable seeds are planted, then 90% are expected to grow into plants. So we have two things that are going to happen again. Either you grow a plant or you don't. So let me define these. So G represents it will grow successfully. G prime represents it will not grow. And so when we have a viable seed or a non-viable seed, there are chances that you will get a plant that grows and a plant that doesn't grow. So now to write in the probabilities, it says if viable seeds are planted, 90% are expected to grow, so 0.9. And the reason why I wrote it here was because it says if viable seeds, so it has to be from this branch, and then moving on. And so again, it doesn't say the probability that it will not grow into plant, but again, we can just do the opposite. 100% minus 90% is just 10%. On the other hand, if non-viable seeds are planted, then 15% are expected to grow, so 0.15. And 100 minus 50% is 0.85. Once we've drawn this diagram, we also want to multiply everything. Just to make things clear, what I meant was to multiply, we want to do like 0.8 times 0.9. So 0.8 times 0.9 is 0.72. 0.8 times 0.1 is 0.08. 0.2 times 0.15 is 0.03. And 0.2 times 0.85 is 0.17. And the reason why I am doing this is because it will help on the problems that we're going to do soon. And what all these basically represents is that for 0.72, it shows the probability that you get a viable seed and that it grows. Here it represents you get a viable seed, but it doesn't grow. Here it shows the probability that you get a non-viable seed, but it grows. And here it shows you get a non-viable seed and it doesn't grow. Now let's try applying what we've learned and making use of this tree diagram and solve some problems. So here, question A, it says probability G prime, so probability of not getting a plant that grows given that you get a viable seed. So it may sound confusing at first because you're not really sure what this represents, but this basically here shows the conditioned probability. So the conditioned probability is you have something like this. And what this basically means is it basically asks, what is the probability that you get A given B? So the formula for that is the probability of A and B happening given B. So remember, when you see this, your mind should always be thinking, okay, so the thing behind this line here shows what is given. We're given B, we want to find the probability of A. So here, in this situation, it's the same, right? Probability of getting a plant that doesn't grow and the probability of getting a viable seed. And we're given that it is a viable seed. So in context, what this basically means is that it's asking, what is the probability that you're going to get a plant that doesn't grow given that it is a viable seed? So the probability of viable seed is 0.8, right? So we're going to put that in, 0.8. And the probability that you get a viable seed and a plant that doesn't grow, when you see this, you always want to do multiplication. But in the beginning, remember, we multiplied all these, right? And so that is what we're going to make use of. So the probability that we get a viable seed and a plant that doesn't grow is 0.8, because 0.8, how we got that was 0.8 times 0.1, and so that is going to be our numerator. And when we solve that, we're going to get 0.1, and that's our answer. So the probability that we get a plant that doesn't grow, given that it is a viable seed, is 0.1. A pretty small chance of happening. Now let's look at another problem here. So this one is actually kind of similar what we did earlier. This is not condition probability, but it is asking a similar idea of the numerator. Pretty much the same actually. It's asking for what is the probability that you get a viable seed and it doesn't grow. And it doesn't grow. You have to multiply, right? So in this case, it will be 0.8 times 0.1, which we already did. It's 0.08. So the probability is just 0.08. Now we have probability of a plant that grows. Now we see that there are two different values. We have the probability that it will grow. We have 0.72 and 0.03. And when you get this basically means something that's happening with or, right? Earlier this represents and, but in this case it's or, right? Because you either are going to get this one or this one, not both. So when it comes to or, we want to make sure to always add the numbers. So we have 0.72 plus 0.03. And we are going to get, when we add them, 0.75. So the probability that we're going to get a plant that grows is going to be 0.75. Last but not least, a slightly more challenging problem. So this one is condition probability again. And what this basically means is, what is the probability that you're going to get a viable seed given that it grows? So given that it grows, what's the probability of, sorry, not B, there it is. So the probability of getting a viable seed and it grows, well, it's going to be 0.8 times 0.9, right? Which is 0.72. And what is the probability of G? Well, we just solved that, right? It's 0.75. So if we divide them, we get 0.96. And there you have it. That's how you do probability making use of tree diagrams and applying that to solve various different situations. Now let's look at another example. So there's a 20% chance that you have homework to do at night. If you have homework, you go to bed early 10% of the time. If you don't have homework, you go to bed early 40% of the time. What is the probability you go to bed early given you had homework? What is the probability you had homework given you went to bed late? So there are two questions here, but right now we're going to ignore that. The first thing we want to do is draw a tree diagram. You always want to draw a tree diagram because it helps with visualizing what is really happening. So if we were to draw the tree diagram, again, there's going to be two things that are happening. And the two things that are going to happen is whether or not you have homework, right? So if you have homework or not. So let me call H as have homework and H prime as no homework. So it says 20% chance that you have homework. So two things are going to happen. Either you have homework or not have homework. And it says 20% chance that you have homework. So 0.2. And the opposite is 100 minus 20%, which is 0.8. And then next it says if you have homework, you go to bed early. So again, there's two things going to happen. Either you go to bed early or you don't. So let's call early. Let's call E as bed, go to bed early, and L, go to bed late. So when you have homework or not, it doesn't matter. Two things are going to happen. You go to bed early or you don't. So it says if you have homework, you go to bed early 10% of the time. So 0.1, and the opposite of that is 0.9. If you don't have homework, you go to bed early 40% of the time. And the opposite of that is 0.6. So it makes sense, right? If you have homework, you're gonna stay up. You're more likely to stay up late to do the homework. And if you don't have homework, you're more likely to sleep early than having homework, even though you still sleep late. And so again, what we want to do when we have tree diagram is multiply everything because it helps with visualization. So 0.2 times 0.1, you get 0.02. 0.2 times 0.9, you get 0.18. And by the way, I'm using my calculator. Feel free to also do it yourself if you like. And last but not least, 0.8 times 0.6, 0.48. So there we have it. Now we can move on to the questions. So the first one, what is the probability you go to bed early given you had homework? So here it basically asks the probability that you go to bed early given you had homework. So making use of our condition probability formula, what we want to do is have the probability that you're given in the denominator. So what's going to happen here basically is the probability of getting E and B. So probability, sorry, why did I keep writing B? I meant H. So the probability that you sleep early and you had homework was 0.02, right? So 0.02 divided by the probability of H. So the probability that you have homework was 0.2, right? So 0.02 divided by 0.2, you get 0.1. Next, what is the probability you had homework given you went to bed late? The probability that you had homework given you went to bed late. And so again, write down clearly what is going to happen. So here, the probability that you're going to get homework and you're going to sleep late is here and here, which is 0.18 divided by the probability of sleeping late. So here you got to be careful, right? Because you have two variables of sleeping late. So this one is an or example. So you're either going to sleep late but you had homework, or you're either going to sleep late but you don't have homework. So again, similar to what we've done before, when it is a question related to or, either or, you're going to sleep late, either this or this, you have to add them. So it would be 0.18 plus 0.48. And in total, you should get 0.2727 approximately. And so there you have it. This is how you do condition probability and other kinds of probability once you've drawn the tree diagram. A major takeaway is you always want to draw a tree diagram because it really helps with visualizing with what's happening. And when you see something like this or this, it is a condition probability. So always refer back to the formula. And if you get something like this, and it has to do with multiplication, if it asks for probability of something, it is an or situation, so you have to add them. Thank you for watching, everyone. I hope this video helps with statistics. Thank you.